kernel and device driver based interview. So this is probably the most important area if you are targeting companies like Qualcomm, NXP, TI, Bosch, AMD, or NVIDIA. Most technical interviews focus heavily on kernel internals and device drivers because this knowledge directly maps to your real world job responsibilities. And you will be expected to understand interrupt handling, memory allocations, synchronizations mechanism like mutex, pin log, wait queues, work queues, and how Linux basically communicate with the hardware through device drivers. If someone asks me where to spend the most time while preparing for a embedded Linux interview, my answer is always kernel internals and the device drivers. And I also list out the companies which mainly hire for the engineers which are coming from Linux background. So you have Qualcomm, TI, NXP, Intel, NVIDIA, Bosch, KPIT, Tata Alexei, Sasken, Ambitel, Continental. So this is a mix of company which have product-based as well as service-based company, right? So now many engineers underestimate C programming after gaining experience, but interviews prove otherwise. Companies continue to ask questions on pointers, memory management, linked list, function pointer, bit manipulation, dynamic memory allocation, structures, union and data structure. So the Linux kernel is one of the largest C code base in the world. Without strong C fundamental, reading or modifying kernel code becomes extremely challenging. So strengthening C is one of the best investment you can make. I have listed out all the topics which you should focus from each of these subtopics of the C programming. So that's what we suggest all of our bootcamp members as well, like what all topics you need to prepare. And we talk about a lot about all these topics and that, right? And the other fundamental which you basically required to prepare for a Mary Linux interview, which is Linux system programming. So before moving into Linux kernel development, you must understand user space programming, which includes processes, thread, signals, socket, file handling, inter-process communication, synchronization, and system calls. A common interview question is how a user's application communicate with the device driver. If you understand Linux system programming well, you will be able to answer such questions confidently. So these are the main topics which I have listed out, like process and signals, thread, IPC mechanism, socket and networking, all right, and then device node interactions. So these are the topics which you should have a good understanding on whenever you are. So it's not only to prepare yourself for the interview, the roadmap which I'm going to talk about, these are suitable even for a person who is basically very new into the embedded Linux world, but they want to start or he wants to start on a embedded Linux journey. Okay, even though you're coming from automotive background, but most of the people we have interacted with till now, they feel like in automotive domain their growth is basically a bit stuck and they want to move to the semiconductor industry. And we always suggest the best way to move from automotive to semiconductor industry is go for the Linux kernel, because you are an experienced engineers. And being an experienced engineers, if you will add Linux skill as part of your resume, maybe a small project as part of your resume which is basically covering Linux kernel and device development. So this will help you to basically gain attention from the companies, mostly the semiconductor companies like Qualcomm, Nvidia, AMD, Broadcom, and all these companies. They will definitely focus on your resume basically. Otherwise your resume will be treated like an automotive resume and you will be not be able to get calls from the companies, uh, semiconductor companies which you are targeting for, right? So this roadmap is suitable even though you are starting just from the beginning, as well as you are already working in embedded Linux side, but you want to focus on into preparation part of embedded Linux, or you want to build your basically profile from scratch, starting from the very beginning, understanding what exactly the Linux kernel is, right? So after Linux system programming, we will move to the kernel internals and device drivers. So basically this is where you will actually start writing Linux kernel module and device driver. You will learn how drivers are registered, how file operations works, how interrupts are handled, how synchronization is implemented, and how memory is allocated inside the kernel. Most companies don't just expect theoretical knowledge, they want engineers who understand how these concepts are applied in real production. And one more thing we want to basically clarify here is most of the time people understand if they know how to work on Linux terminal, if they know few commands of Linux that are sufficient to basically meet the eligible criteria for applying for these companies. No, that's not true basically. Knowing Linux, they expect you to understand Linux kernel and device driver. They expect you to have at least one small project which you have done as part of your Linux kernel and device driver development, which you can show them, showcase them basically in the interviews, as well as you can talk about that in the interview, right? So if you want to understand Linux kernel and device driver in deep, so these are the few topics which you should focus. You should understand what exactly kernel modules are, how to write a character driver, what is the importance of character driver in embedded Linux, and then interrupt handling. Whether you're coming from any background of embedded system, interrupt handling will be the first thing you should focus upon, and most of the time you will face questions around interrupt handling in your interviews. And the second important topic is concurrency and the sync. Basically, you have to understand what is exactly spin log, what is exactly mutex. And also, yesterday we were taking a live sessions of our bootcamp members. So someone just asked, like, earlier when they used to go for interviews, interviewer was just asking what exactly the difference between spin leg and mutex. But nowadays the grilling is more, considering the impact of AI in our on our jobs. So anyway, we have a lot of peoples available in the industries because of the layoff just happened throughout the industry basically. So competition is quite tough, so that is why they go and in deep. Basically, they will ask each and every questions in deep to understand what exactly your expertise is, right? So definitely competition is getting tougher day by day, so we cannot skip that part actually, right? And then embedded Linux fundamentals. So embedded Linux is much more than the kernel. Basically, most of the time people think like if they know Linux kernel and device driver, that is done, but not exactly like that. Embedded Linux fundamentals is basically much more than the kernel actually. So you will also need to understand how the system boots, how the bootloader works, how the kernel is configured, how device to describe hardware, and how build root for Yocto generates the final operating system. And understanding the complete boot flow basically helps you to troubleshoot boot issues and work confidently on embedded platforms. Right. So here I have listed out the fundamentals which you can focus on. Definitely for a single engineer, it is not expected you know each and everything in the detail, but at least you should have a high level understanding of the topics which you are utilizing in your day-to-day task in your embedded Linux world. Okay, it could be cross compilation, like how exactly you're compiling your project to be deployed on some other XYZ chipset, right? And then the bootloader kernel configuration, basically what are the different kernel configurations are available in Linux kernel. It could be menu config, it could be X config, right? So all those things which we basically should have focus upon. And then device tree, like it's a most important topic I would say we should focus upon. Definitely you can expect questions around that as well. Then root file system, Yocto, build root. So these are the other area which you can focus whenever you are preparing for the interviews, right? And one of the biggest difference between a beginner and an experienced engineer is basically debugging. So real project spends much more time debugging than writing new code, and that is also true. Like, I am in this Linux kernel device dev industry from last 14 15 years basically, and it's very rare you will get chance to write the driver from scratch, at least in current industry, because most of the time you will get reference of the driver which is already available through the OEM's vendor or maybe internet. So only thing you are going to do is you are going to port your driver. So when you will port the existing driver, so definitely you will face a lot of issues. So I want to convey the point here is 90% of the time of your job you will be working on debugging the issues basically, right? And the real project basically, as I mentioned, spend much more time debugging than writing the new code. And learning tools like GDB, strace, perf, ftrace, kgdb, well-grained help you to identify issues quickly and improve your productivity significantly. Interviewer also appreciate candidate who can explain how they debug real problems, right? And then testing and practice basically, that is the, of course, the requirement here is knowledge becomes valuable when you only apply it, right? So that's why I always recommend writing drivers, reading Linux source code, solving interview questions, practicing or participating in mock interviews and debugging the real issues. So practice builds confidence, and confidence reflects clearly during the interviews, right? So most of the time people will come and say like they don't have a source code ready, or they don't have the actual hardware to practice upon. You don't need, and you have availability of everything. If you don't have hardware, you can use a lot of simulations available in the market. You can use QEMU. Through that you can simulate 90% of the stuff basically, and you can learn whatever the way you want to, right? For the kernel source, understanding kernel source, kernel.org is the basically mainline kernel code repository which you can follow. You can understand the code, you can go through it, you can spend some time on it. It will give you the idea of Linux kernel, as well as it will give you how exactly the real code is written, because this code is being modified or maintained by thousands of maintainers around the world. So by reading this code, you will not just understand Linux kernel, you will also understand like how other engineers think, how exactly they implement the real life problems, how they solve the real life problems basically, and what exactly their methodology of writing the code. So that you can learn by their own experience basically, right? And then small projects you can practice like GPU driver, I2C driver, platform drivers, character drivers basically, right? And then if you are specifically targeting few companies, so definitely you should have specific entry preparation as part of that as well. So for Qualcomm, you can go over the Snapdragon kernel. For TI, you can focus on AM62 DMA remote probe. For NXP basically you can focus on device tree, pinmux, IMX8. And for NVIDIA, you can focus on PCI, GPU drivers basically, and then Tegra SoCs, right? So these are the few things which you should focus upon. Now, most of the time, people comes to me and ask like, what exactly the books they should follow, what are exactly the resources they should follow whenever they are basically preparing for, or they want to get skills in Linux kernel. So there are three books which I have specified. One is like Kernel Bible, I would say, Linux Kernel Development by Robert Lowe. Although this book is quite old and we have not seen any latest update on that, but that will still help to get you the basic understanding of Linux kernel. And then the second is Essential Linux Device Driver by Sri Krishnan Venkateswaran. This is also one of the good book I would recommend. And the third book is Linux Device Driver by Corbett. Okay, so these books have helped thousands of engineers understanding Linux at a much deeper level, right? So now that you have seen the roadmap, the next question is usually how do I actually learn all of this in a structured way? So that's exactly why we have designed this 8-week Linux kernel and device development program. So the curriculum starts from kernel fundamentals, gradually move into device driver development, then covers advanced topics like synchronization, interrupt, wait queue, device tree, platform driver, and kernel debugging. So the goal is not just to teach concepts, but to help you become confident enough to clear interviews and work on real projects. So how this training basically works? So this training is designed for working professional. Every week you will receive 3 recorded sessions that you can watch at your own pace. On weekend we will have live doubt sessions where you can ask questions, discuss assignment, and interact directly with me. So this flexible format allow you to continue learning without affecting your current schedule, right? So as a thank you for attending today's webinar, we are offering an exclusive 20% discount using the coupon code WEB20. Let me ping you the course link also in the chat, because we will be closing enrollment today and this code will expire in next 30 minutes. So if you want to enroll it for, we are starting the new batch starting from tomorrow actually. You can focus on that. Okay, so the next batch basically starting tomorrow. So this is a great opportunity to begin your Linux kernel journey without dealing it further. If you're serious about transitioning into product based companies or strengthening your embedded Linux skills, I would love to have you in this upcoming batch. Okay, so now the, if you have any questions you can go over it, and please note whatever the link I have shared in the chat, this is our course link and you can use the discount code which I'm just mentioning in the chat. So this will be valid only till next 30 minutes. After that, we'll be closing enrollment for this batch, which we are starting from tomorrow. Now, if you have any question, you can type your question in the chat. I will love to help you in that. And before that, I also want to highlight one of the things. We have recently developed a hiring portal for our bootcamp members, as well as the member who are going to participate in this embedded Linux training. So this is private hiring portal which will help them to get the referrals from our own community. So this portal will be live this week. So all our bootcamp members as well as our training joiners will get access to this private hiring portal. Okay. Yeah. So if you have any, type in the chat. Okay. So Harshal is asking. Okay. So embedded hiring portal, Harshal already mentioned like he is in the boot camp. So this will be, you will be getting access this week Wednesday. We are making it live basically. Okay. Can I start? Can I study kernel from free autos? You can do that, Karthik, and you can do that. But like it's a autos free autos kernel. So this is different than Linux kernel basically. If you will learn it from free autos, then you will understand the autos kernel, not exactly the Linux kernel. So Jitesh asked question. This is Jitesh currently pursuing final year in EC. Should I start my career as embedded firmware engineer and later move towards embedded Linux, or should I directly you can directly start from where, because see the competition in embedded Linux is quite low as compared to whatever you have in other like firmware as well as RTOS, because most of the people who is coming fresh out of the college, they will focus upon either RTOS or either bare metal, right? So there basically you will find a lot of competition, right? So Nikhil is asking, this training will start from scratch. Yes, this training will start from scratch if you have basic understanding of C programming. So that's enough for you to start about this training basically. Okay, and then Bhaskar is asking, I'm having 15 plus experience in Android middleware. Will this course useful for me to get into LDD? Definitely, Bhaskar, because you already have experience in the middleware. So if you will understand the lower layer through this training, basically, so you can put that in your resume, and that will definitely help you. Bhagya Raju is asking, like, having 6 years of experience in bare metal.